Welcome back, everyone. In this last video of this short chapter in our course, we're going to look at the new operator type known in Java as unary operators. Before starting into looking at them, one of the reasons why they're called unary operators is because they change the value of a variable by a single unit. So you remember our compound operators from our previous video? We looked at how you can simplify an addition and assignment or all the other arithmetic operators and assign it into one. So here you can change the value by 2, by 5, by however much you want to. However, with unary operators, you're going to be able to change them only by 1. So from our previous example, variable is equal to variable by 5 cannot be converted into a unary operator, cannot be converted into a unary, whereas var is equal to var plus 1 or var is equal to var minus 1. These are great candidates for unary operators. Candidates for unary operators. Okay. Now, the reason why we say these are great candidates for unary operators is because unary operators, there are two types of them out there. One is plus plus, another one is minus minus. If you see, there is no equal to. This is just plus plus. This resembles the same as, for example, var plus equal to 1. So see how much we decrease this further, and the syntax of this unary operator is going to be var plus plus. So Java even allows us to take out this statement and shorten it to this statement. That's it. The same is here. Var minus equal to 1 is the same as var minus minus. Okay, now we will see why Java developers found the need to do this, because we will use them a lot when we look into our future topics. So get comfortable with using them. Now, before we move on into certain tricks of unary operators, there are two types of unary operators, as we saw above. This is called increment. Increases the value by 1. Increment. This is called decrement. Decreases the value by 1. Now, increments and decrements can be of two types as well. Types of increment, decrement operations. One is prefix. So example grati. We said above var plus plus. You remember how we said var plus plus? Prefix will be plus plus var. So you can take the plus plus from the end of the statement and add it to the beginning before even the variable. And postfix. Example grati var plus plus, the one we saw above. So this is postfix. If you put the increment or decrement, let's actually add decrement 2, because we have two types anyways. If you do this, var minus minus. So if you put these increment or decrement operations after, they're called postfix. If you put them before, they're going to be called prefix. Now, let's go back to our eclipses and let's look into some operations on our IDE. We're going to call this unary demo class. This is going to belong to section 3_4 package. Created. Now I'm going to show, I'm not going to follow our suit of creating additional method, because right now we will see these increment and decrement operations in action through our main method, and we will not spend time on creating additional one. So let's basically create two variables, actually three variables. Int num1 is equal to, equal to 5. Int num2 is equal to 3. And we're going to create int temp, just in case we need to use it down the road. Now, let's demonstrate postfix, increment, and decrement. Okay. Postfix is, we're going to start with postfix because this is most commonly used option, right? This is where we put the increment and decrement operators after the variable. Now, let me do this. This is how we say num1 plus plus. For example, we took num1, its value was 5. We increased it. And when I try to print out num1 now, so I'm going to do first post increment. I can call it this too, postfix. It can be called post increment or post decrement, and I'm gonna print out num1. So what do you think will be displayed on my console when I print this out? You need a second, pause the video, answer the question, get back to us. Okay, now when I do this, what happens is I just take the number 5 and add 1 to it, right? And assign it back to num1. When I run it, I get 6. I had 5 as assigned to number 1. Now I increased 5 by 1, I get 6. Okay? Now let's do this. Let's take this and post increment inside, I have a typo, increment inside print line. Or let's call it by short name. And this is what I'm going to do, num1 plus plus. What do you think is going to print here? Is it going to be 7? Is it going to be, because right now it's 6, right? Don't forget, here we have a value of 6. So let's do this. Num1 has a value 6. So here it's just supposed to print 7, right? Let's run it. But it printed 6 again. So that's why this is called post increment. So this is the functionality of post increment. When you add increment or decrement operation per se after the variable, what Java does, Java starts line 14, executing line 14. It prints out this string. It concatenates the value of num1. Then it sees, okay, I need to increase this, right? So it holds this in memory. After this statement is complete, it creates, after the statement above is complete, Java remembers to increment and assign 1 to num1. So if in the next printout I say after pi inside print line, oops, let me do this. Oh, let me add space. And I'm just going to create num1. I'm just going to print out num1 itself. I'm not going to do anything to it. And when I run it, it's going to show me 7. I didn't increase it, right? I didn't increment it or decrement it. But the 7 is caused by us using post increment operation in this line, in line 14. And what happened is Java did not execute it right away. Java said, let me wait for this statement to complete, then I'm going to execute it from my memory and reassign value to num1, right? Right here. So currently num1 is 6 here. Num1 is still 6 inside the print line. And then in this here, num1, even though it's empty, no statements, no executions, no expressions, Java goes from the memory is now increased by 1 before doing anything else. Okay? So that is how post increment works. Let's now demo the prefix operation. Increment, right? decrement is going to work the same way. So prefix increment. And this time we're going to look at num2 because we're going to leave num1 there. We're not going to touch it. We're going to look at num2. So num2, oh, I'm sorry, plus plus num2. This we're looking at prefix increment, right? Okay. Let's print out first pre-increment or pre-increment of num2, so we can distinguish between them on our display num2, right? So what do you think the output is going to be? Num2 was 3 before. What do you think it's going to be printed out here? Pause it, answer, get back to us. Answer is going to be simple. It is just going to do the regular incrementation, and this will become 4, right? So we printed out first pre-increment of num2. Great. Now, let's take this incrementation operation that we did before is in a separate statement, add it inside our method. System out, pre-increment inside print line. And I'm going to say plus plus num2. So here, let's keep in our memory that num2 is what? 2. Oh, I'm sorry. Num2, oh, I'm sorry, we're talking about increment. Num2 is 4, right? Because we're adding to num2. So it was 3 before. Now we added to it, and num2 holds a value of 4. Now, before we run this statement, num2 has a value of 4. What do you think this statement will display on the console when we have pre-increment operation inside the print line? Pause, answer, get back to us. Okay. If you think that this is going to act the same way as it was in the post increment, think again. There is a reason why we call it pre-increment. When I run this print line, unlike this here, where we said Java will remember to increment it later, Java will say, you know what, before I even execute this whole thing, I will stop the execution, do my pre-increment, execute it first, assign my value, then print out num2. Run it. You're going to get 5. Okay? I'm going to say, unlike post increment, I'm going to continue my comments here. When Java compiler sees pre-increment, I should have used other type of commenting. It drops everything, completes pre-increment, then continues. So when Java sees this, put yourself in the shoes of the compiler. Okay, hold on. Let me do this operation first. Num2 was 4, now it is 5. Great, now let's continue. And then if I want to see the value of after pre-inc inside print line, oops, num2, when I run it, my value is going to stay same as 5. If you see, with postfix, our value is assigned after the statement that postfix is inside is complete, but in prefix, it is assigned right there. The same applies to decrement. We looked at increments, we looked at decrements. The same applies to decrements. I'm not going to repeat the code for decrements. Try it. So stop the video, try it on your own, try pre, try post. Our content materials, our written materials have, our reading materials have all the examples that will show you. Before I close this topic though, I want to show you a couple things. Tricks. Look at this operation. For example, num2. Okay, let's do this. Temp is now equal to num2, right? And what I'm gonna do is, before that, I'm gonna say temp equal to plus plus num2. So put yourself in the compiler's shoe. What happened? Num2's value just increased from here. It is what? Here it is 5. The same applies here because we incremented it right away. So I'm gonna say num2 5, right? So num2's value is 5. Num2 is 5. What do we see here? Pre-increment. Now num2 is 6. Temp is equal to num2 being 6, right? So in that case, temp is equal to 6, correct? Plus temp. Do we see any issues here? We have an error. Where is this error coming from? Invalid argument plus. Okay. How about this? Okay. So what's its name? In IDE, when we put 3 pluses next to each other, it complains. It will not let you to. But when it comes to certification examinations and written printouts, you will see this. When you see this, you should understand that there is no triple plus operation in Java. I can tell you that up front. We will not see any surprise operator like that. There is only the maximum pluses or minuses you can put next to each other are going to be increments and decrements. So this first plus sign is a concatenation operation or overloaded plus operation. Now the second two, these are pre-increment operations. So when you see triple pluses, you can't put it in your compiler, but on the paper, when you see it, just add a space to it and think about it, what's going on. There is another trick here. We said that num2 was 5. Now it is 6, so temp is 6. What do you think the output of this print line is going to be? 6? If you think so, think one more time. Temp was 6 here, and before we print this out, we're going to increment temp by 1. Now it should print out 7. Run it. You see, is now equal to num2. This is a wrong statement. Temp is not equal to num2. Temp is equal to used to be equal to num2, but now it is 7. So this might be one of the trick questions. The same applies to, for example, let me show you one more trick question. If num2 is greater than our current value of num2, let's actually do this. Our current value of num2 is 6, correct? So let's add note to ourselves, 6. If num2 is greater than 7, which is not the case, or actually do this, let's num2 plus is greater than 7, and plus temp is, I don't know, temp was 7 now, right? Greater than or equal to, greater than or equal to 7. Them out. Num2 is greater than 7, right? Now, system out, current value of temp. You remember our short circuit conditional operators who said we have double ANDs and we can use single AND. We ampersands for AND operation. We have short circuit OR operation, and we have no circuit like a regular OR operation. And we said that to increase efficiency and speed, we are going to mostly opt out for short circuit operators, right? But this is another trick question when you see in the examinations. We said that if we have a short circuit operation, if the first part, in the case of AND, if the first left-hand side of this operation returns false, we are not going to check for right-hand side of operation, because even if it returns true, we don't care. We have false, and our default for the AND operation is false. We got our false. We're not going to run this, correct? Now, if we don't have short circuit AND operator, even though this returns false because the value of num2 is 6, right? It's not greater than 7. So even though this is false, we are still going to check for the right-hand side operation. And when we check for right-hand side operation, this might be true, this might be false, it doesn't matter, but we will run this statement, correct? And when we run this statement, we come across pre-increment before temp. And what we said above, anytime Java runs any kind of a statement that has pre-increment operation inside, Java is going to stop everything, run this first, assign it, then continue looking at it. Okay, so in this case, temp is not going to print 7, right? Temp is going to print 8. Even though this is false, when we touch this operation here, because we don't have a short circuit operation, since we touch this operation here, our temp's value has just been upgraded. Congratulations. So this is not going to be printed because this is false. This statement is not going to run inside the if block. But since we had a single ampersand, we did not have short circuit, our temp value has just been upgraded before everything else, correct? Before everything else from this moment on, correct? Now, we have temp as 8 now. This is not a trick question in examinations and everything, or you might actually get this question from someone who wants to see how detail oriented you are. Let's do this. Let's rewrite this code and add another ampersand here and make this a short circuit if condition. When I run it, my temp value will not change, because what Java sees here is, it comes here, oh, this is false, what operation do I have? AND operation. I do not touch it, right? Now it is 7. However, when I say, you know what, just check for the both sides, then look at the operation, right? When I do this and I run it, look at how my value again is 8. Practice on these things, practice on pre and post increments. I can say that our most common usage will be post increment. Pre increments can be used in certain cases when we have a specific logic, but your most common use is going to be post increment. Do get comfortable with pre increments. Do put yourself in the compiler. Every time you see pre increment, stop everything on that line of execution. Do that first, assign it to the variable, then come back. If you see this kind of questions in examinations or anywhere that or interviews, or you see someone's code with these kind of tricky or this kind of a trick, do not fall for it. Read the code, understand every single line, put yourself in compiler shoes, say that if I was a compiler, how would I act? And then everything will be self-explanatory for you. I want to thank you for your time. I want to encourage you to practice on these concepts. We will get in a lot of opportunity to practice on increments and decrements. I did not demonstrate decrement, but the logic is the same. It's just instead of increasing values, decrement simply decreases values by 1. Practice that on your own. Take this whole code, rewrite it in all decrements, see what you get. I thank you for your time, and I will see you in our next videos.